Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Data File Handling, Part 7, for the Class 12 students of Computer Science. In this video, we are going to learn binary operations, inserting or appending a record in a binary file, reading a record from a binary file, searching a record in a binary file, updating a record in a binary file, and practical implementation. So, let's dive in and get started. We already learned in the previous video about Python pickle module. Pickle module can be used to store any kind of object in a binary file as it allows us to store Python objects with their structure. For storing data in a binary format, we will use pickle module. We also learned the steps to perform read and write operations on a binary file. Mainly we learned about importing pickle module using import pickle statement. It provides two main methods, dump and load. The syntax of dump method is dump, object, file object. Syntax of load method is object equals load of file object. Binary files store data in a format that is not human readable and is optimized for efficiency. Here are 4 major operations that can be performed using binary files in programming. Inserting or appending a record in a binary file, reading a record from a binary file, searching a record in a binary file, and updating a record in a binary file. Let's see one by one in detail. Let's see about inserting or appending a record into a binary file. Inserting or appending a record into a binary file requires importing pickle module into your program followed by dump method to write onto the file. Let's see an example. Now, look at the Python code. In line 2, it starts by importing the pickle module, which allows for easy serialization and deserialization of Python objects. In line 3, an empty list called record is created to store the student records. In line 4, 5, 6, 7, a loop is used to repeatedly take input from the user for roll number, name, and marks of the student. In line 8, this data is then packed into a list called data. In line 9, the data list is appended to the record list, creating a list of lists containing all the student records. In line 10, 11, 12, the user is asked whether they want to add more records. If the user enters n, case insensitive, the loop breaks. In line 13, the file student is opened in binary write mode, WB. This creates or overwrites the file if it already exists. In line 14, the pickle.dump function is used to serialize the record list and write it to the file. In line 15, a message is printed to indicate that the record has been added. In line 16, finally, the file is closed using f.close to ensure proper resource management. So now look at the right side of the screen. The input is accepted from the user. The user is prompted to enter the roll number, name, marks. If the user wished to add more records, the user presses Y for yes and adds some more records. If he pressed N for no, the message displays record added. So, where is the record added? The record is now added into the student file. So now, look at the below screen. When we open the student file, you can see the contents of the student details which we have entered in binary write mode, where the contents are in binary form, which is not human readable. It is difficult to read and understand, but it is directly used and understood by the computer. So, once again, I summarize this example of inserting or appending a record into a binary file. In this code, inserting and adding a record in student file begins with importing pickle module. Then, iterating for the number of records to be added is done using while loop. Input is accepted from the user for roll number, name and marks. These fetched values are saved as a list to be appended. Once the record is created, it is appended to the binary file student using the dump method, which writes the object onto the opened file. Finally, the file is closed explicitly and the record is added into the student.d file as shown below the screen, in the output, which is in binary form, unreadable characters, but understood by the computer. Now, let's see about reading a record from a binary file. That is, how a record is read from a binary file. This Python program demonstrates how to read records from a binary file named student.dat using the pickle module. The student.dat file contains serialized objects that represent student records, each containing information like roll number, name, and marks. Now, look at the Python code. In line 2, import the pickle module, which is used for serializing and deserializing Python objects. In line 3, open the binary file student in read mode, RB. The RB mode stands for read binary, which is used to read binary files. In line 4, use pickle.load of f to deserialize the object stored in the binary file. This line reads the serialized data from the file and reconstructs the original Python object. In this case, the serialized object represents a list of student records. In line 5, print a message indicating the contents of the student file are going to be displayed. In line 7, 8, 9, 10, loop through each record in the student_record list. Inside the loop, extract the roll number, name, and marks from the current record, R, by indexing the list. The roll number is at index 0, the name is at index 1, and the marks are at index 2. In line 11, print the extracted roll number, name, and marks using the print function. In line 12, close the file using the f.close statement to free up system resources. Now, once again I summarize this example of reading a record from the binary file student.dat. This program deals with reading the contents from binary file student using load method of pickle module. It is used to read the object from the opened file. The syntax for this is given by the statement object equals pickle.load of file. Once the contents are read, it gets stored inside the object student_record. All the data of the respective fields from this object is held in the respective variables, roll_number, name, and marks, and are finally displayed as the output. You can check the output displayed on the console. Now, let's see about searching a record in a binary file. Program to search a record from the binary file student.dat in the basis of roll number. Now, look at the Python code. This Python code is a program that reads records from a binary file named student.dat and searches for a specific student's information based on their roll number. The program uses the pickle module to serialize and deserialize Python objects for storing and retrieving data from the binary file. Now, look at line 2. The import pickle statement imports the pickle module, which provides functionality for serializing and deserializing Python objects. In line 3, the f equals open student RB line opens the file named student in binary read mode RB. This means that the file is opened for reading as binary data. In line 4, the student_record equals pickle.load f line reads the object stored in the binary file using the pickle.load function. This object is expected to be a list of student records. The contents of the binary file are deserialized into the student_record variable. In line 5, it sets the found variable to 0. In line 6, the program then prompts the user to enter a roll number to search for using the RNO equals int of input of enter the roll number to search line. The user is expected to input an integer roll number. In line 7, the code enters a loop using for r in student_record to iterate through each student record in the student_record list. In line 8, inside the loop, the program checks if the roll number, r of 0, of the current record matches the roll number entered by the user, or no. In line 9, if a match is found, it prints a message indicating a successful search and displays the student's name, r of 1. In line 10, it then sets the found variable to 1 to indicate that the record was found, and breaks out of the loop using break. In line 12, after the loop completes, the program checks if the found variable is still 0. If found is 0, it means that no record with the specified roll number was found, so, in line 13, it prints a record not found message. In line 14, finally, the code closes the binary file using f.close to release the resources associated with the file. Let's recall. This code reads a list of student records from a binary file, allows the user to input a roll number, and searches for a matching student record. If a matching record is found, it prints the student's name. If no matching record is found, it prints an error message. Now, look at the contents of the student file in the right side of the screen for your reference. Now, look at the output. When the roll number is entered as 1111, the output is, successful search Alice found. When roll number is given as 1118, which is not in the student file, the message displayed is sorry, record not found. Now, let's see about updating a record in a binary file. Program to update the name of the student from the binary file. This program requires roll number to be fetched from the user whose name is to be update. This Python code is a program that allows you to update the name of a student in a binary file containing student records. The program uses the pickle module for reading and writing data in a serialized format. Now, look at line 2. The code begins by importing the pickle module with the line import pickle. In line 3, the f equals open, student, rb+, line opens the file named student in binary read and write mode, rb+. This means the file is opened for both reading and writing binary data. In line 4, the student_record equals pickle.load of f line reads the object stored in the binary file using the pickle.load function. The object is expected to be a list of student records. The contents of the binary file are deserialized into the student_record variable. In line 5, it is set 0 to the variable found. In line 6, the program then prompts the user to enter a roll number to search for using the rollno equals int of, input of, enter the roll number to search, line. The user is expected to input an integer roll number. In line 7, the code enters a loop using for r in student_record to iterate through each student record in the student_record list. In line 8, inside the loop, the program extracts the roll number from the current student record with our number equals r of 0. In line 9, the code then checks if the extracted roll number, rno, matches the roll number entered by the user, rollno. In line 10, if a match is found, it prints the current name of the student, r of 1, then in line 11, it prompts the user for a new name with r of 1 equals input of, new name. In line 12, after updating the name, the found variable is set to 1 to indicate that the record was found, and the loop is broken using break in line 13. In line 14 and 15, if a record was found, that is, found equals 1, the program seeks the beginning of the file using f.seek of 0 to ensure that the file pointer is positioned at the start of the file. In line 16, the updated student_record list is then written back into the binary file using pickle.dump of student_record, f to overwrite the existing data with the updated student record. Finally, in line 17, the program prints a message indicating that the name has been updated, and in line 18, the file is closed using f.close method to release the resources associated with the file. In line 19, after updating the student record in the binary file, the code reopens the same binary file in read mode using f equals open, student, rb. In line 20, the line student_record equals pickle.load, f, reads the updated object from the binary file, which now contains the modified student records after the name update. In line 21, the file is then closed again using f.close to release its resources. In line 22, finally, the print, student_record, line prints the entire student_record list, showing the updated records. This part of the code is intended to display the modified student records after updating the name. It's a way to confirm that the name update was successful and that the changes were saved in the binary file. In summary, the entire code reads student records, allows the user to update a student's name based on a roll number, writes the updated records back to the binary file, and then reopens and prints the updated records to verify the changes. Let's check the output on the console. The roll number to be searched is given as 1110. Current name is Sam. We update the new name Alex. So now, you can see in roll number 1110, new name Alex is updated. Thanks for watching. Watch the upcoming videos. Data File Handling, Part 8. Random Access in File using tel and seek. You can check the link in the description box given below.